In this video, we will learn how to implement Open Sound Control or OSC protocol for networking with CasparCG server. Thereafter, we will show how to visualize the audio data. Only 3 essential steps are required. First, implement Windows socket and OSC. Second, register and filter OSC messages for individual channels. Third, display the audio. So let's get started. There are many notable software and hardware with OSC implementation like QLab, Module 8, JUCE, Unreal Engine, etc. For this tutorial, CasparCG server, which is a professional player server, has been used. OSC is a content format developed at CNMAT by Adrian Fried and Matt Wright. Implementation of a network socket has already been covered in my earlier video. We will continue this tutorial from where we left off. Copy the folders IP and OSC from GitHub to your project. Include the 3 headers files under these new folders. Extend the class OSC packet listener under namespace OSC and overwrite the virtual member function process message to register and filter the OSC messages. These filter specifications can be obtained from CasparCG website. Let's set up to register and filter channel 1 audio. It's important to implement exception handling to take care of errors in the network stream. Create the OSC socket using the command UDP listening receive socket on default port 6250. Since the OSC socket listener is a blocking function, create an OSC thread to call the function run until sigint to complete. This completes the OSC implementation part. In CasparCG, OSC socket carries real-time media information such as audio levels, current play time, duration of media. A full video playout system supporting playlist can be implemented. OSC messages consist of an address pattern, a type tag string, arguments and an optional time tag. Address patterns form a hierarchical namespace. During startup of the application, call the functions GDI plus startup, launch digital audio thread, create socket, and run OSC. Implementation of the graphics is not extensively covered in this video, however I will share the code in the comment section. GDI Plus has been used to draw the audio bars. It is integrated with Visual C++ and not additional library is required. Since the audio graphic will be updated every fraction of a second, a separate thread has been created for the visualization under the function name, launch digital audio thread. In application design, it is important to keep the GUI module as light as possible to make it very responsive. All the processor-hungry functions should be handled by worker threads. 3 graphics layer are drawn: audio grid, audio color bar and the green bar. The channel audio value from the OSC socket is fairly large number. For representing on the log scale, we take the logarithm, followed by the exponent of the channel audio. Proper scaling has to be carried out for production environment. Call GDI plus startup during initialization and GDI plus shutdown before close of the application. The atomic variable shutdown has been used to terminate the threads when the application closes. Now, start the CasparCG server, then compile and run our application. That's all, folks. Thanks for watching. Please like and subscribe to my channel.